Very good afternoon to everyone. I hope you are not getting nightmares about the visualization, about MS Excel. So how was your session, any of you? How was the session of last 2 days? So if any of you could summarize like what you have done, so that would be helpful in today's session. All of you have right to speak. So any of you? I just want to know the topics, whatever you have covered. What did you cover in the last session?
Ma'am, we have done data visualization on Excel sheet only, and pivot table, charts, and how to create a dashboard.
Okay, so what type of charts you did?
All kinds, like bar charts, area chart, line charts.
Scatter plot.
Yes, and also how to do the slicer and how to connect all the slicers on the dashboard.
Okay, perfect. So today we are the content, okay, bubble chart, etc. Perfect. Data visualization you have covered. So today we are going to work on data analysis, right? Data analysis is equally important if you're writing any research paper, if you are writing your thesis, doing your research analysis, if you're collecting data, be it a primary data or secondary data. So for today's session, we'll be doing data analysis, simple linear regression or multiple regression in MS Excel, right? On day 4 and day 5, you will be doing data analysis, EDA and the CFA, I guess, factor analysis in SPSS, right? So that would be a hands-on exercise. Okay. All right. So the flow of the today's session would be, first I'll tell you how to install the package that you would be working on for the today's session, right? Second, how to generate descriptive statistics. Third is how to create histogram frequency table, right? And fourth is how to create percentile table. And then fifth is regression model. And one more, correlation as well. So the flow would be like this, right? So we are starting. I have shared one Excel sheet on the WhatsApp group. Okay, I'll share it here as well, but it is asking me to close the sheet first. So just give me a second. Okay, so I am sharing the file here as well. For your reference, I have shared this data file on the WhatsApp group as well. Okay, so we'll be working on this file. All right, now I'll share the screen. So it is there in the chat box for everyone. So please download this file for today's session. All right. Okay, so I'm sharing the screen. So is this visible?
Yes, ma'am.
Yes, ma'am.
Yes. Okay, perfect. So this is random data set. Like I was working on something, so I collected the data file from there only. So you can work on your research file, okay, as per your convenience. So, right. So this is like random data. So you need to open this sheet data, okay, not the exercise data. That would be your exercise, right? So this is your data. Okay, data sheet you need to open. So the first step is we will install the tool pack, analysis tool pack. So those who have already this tool pack in the Excel, how to check that? Basically go to data, right? If you go there, this one option, if you click on data, this data analysis. If this data analysis option is there, under data, it means tool pack is already installed in your Excel, right? And those who do not have this option data analysis, what they can do, I'll tell you. You go to file, file, and then go to options. Okay, if options are not there in some of the computers, what they can do, add in option is there. So click on add in, then on options, right? So click on options. Okay, and then here add-ins. Right, click on add-ins. Then the first option is, see here, my active application add-ins is analysis toolpack. So analysis toolpack must be under this inactive application add-ins. Okay, so click on this and then click here, go. Right, you will get this option. Right, so do not install all these things for the time being, just install this analysis toolpack, this toolpack. Okay, and click on OK. So if you click on OK, you will get this option, data analysis, here under data. Clear? Should I repeat?
Yes, ma'am. Please repeat on.
Okay. Step number 1, go to file. Okay, go to file. Second is go to options. Go to options, right? Under options, go to add-ins.
Yes, ma'am.
Okay, then under add-ins, click on wherever it is written analysis toolpack. Click on that and do not click on OK. Then click on from here, go. Manage Excel add-ins, go. Click on go.
Okay.
Right, and then pick this thing, analysis toolpack, and click on OK.
Okay.
Okay.
Yes.
Analyze data is different. Analyze data is on home page, I guess. Under home, it is analyze data. This thing is different, that you already, like, I guess Dr. Monica worked on this yesterday, analyze data feature, right? Do not do this. Like, go to data here from this tab, here from this panel, go to data and check here if data analysis is there. Okay, so Priyadarshini Chaturvedi ji, please install this tool pack. Data analysis, analyze data is not the right option. In my case, options is not visible. So then, Satbir ji, what is visible? Add-ins is visible? Add-ins. Under file. Under file, what options do you have? Under file, do you have add-ins? If you have add-ins, you can go to add-ins. Then could you please like share the screenshot? What options do you have under file? Yes, you can share, just share it. I guess you have right to share. Mobinji, he has right to share the screen. Is it?
Yes, yes, ma'am.
Yes, you
First
have right.
Now first you have to unshare your screen, then only they can share.
Okay, okay. Yeah, thank you. So now, Satbirji, please share your screen. Click on more, more. Under more options, yes. Now add-ins, add-ins. Second last, add-ins. No, not okay. Add-ins. Yeah. Now analysis toolpack. Under inactive application first. Yes. Click, then go. Not okay. Click on go. No, not okay. Go. Yes. Tick this. Okay, okay, okay. Yeah, now it must be there under data tab. Just check it. Go to data, data. Data, this data, no, after formulas, data. Next to formulas, there is a data tab. Go to data tab. Yes, data analysis is there. All right. Okay, now please unshare this. Yeah, I'll share my screen. Okay. So I hope everybody like have installed this tool pack. Yes.
Yes, ma'am.
Or should I repeat anything if any of you have not installed? Because if you have not installed, it is not possible to continue with this today's session, right? Clear? Okay. So wait. Yeah. This one. Okay. Share. All right. So now all of you have access to this, right? All of you have access to this data file as well as this tool pack data analysis. All right. So this is the first step. My screen is visible. All right. Yes. Yeah. Recording of these sessions will be there. What happened, Priyadarshini ji? You have not installed the tool pack. Should I repeat? Okay. All right. All right, so second step is I said I will tell you the descriptive statistics. Okay, you have done it. Descriptive statistics. So any of you have any idea what do you mean by descriptive statistics? What all indicators are there under descriptive statistics? If any of you could answer. Anyone? Under descriptive statistics, you must have read research papers, right? You must have write research paper. Under research paper, the first point for data handling is that you just check the descriptive statistics of any data series, right? Okay, so like, yes, Komal?
So, ma'am, one of the type is measures of frequency, central tendency, then variation.
Right. Okay, so measure of central tendency, as BG also mentioned, mean, median, mode is there. Then measure of dispersion, that is standard deviation is there, right? Then your skewness, kurtosis, right? Maximum, minimum values are there, right? So overall, like visualization you get, not like graphical representation, but tabular representation of your data. Now, how to do this? Okay, so what type of data it is? This data, can you tell me what type of data this is? You must have read the types of data, different types of data. There are 3 types of data. No, I'm not talking about primary or secondary, right? 3 data types. Time series, cross-sectional, panel data. So which type of data this is? Any of you?
Time series?
Time series data, yes. Okay, so numerical, continuous, discrete, that is also there, but this is time series. If you have read about the type of data, then this is time series data where time is there and variables are there. Okay, right? So this is a time series data. Okay, so now how to calculate the descriptive statistics? For example, I want to know the descriptive statistics of this series. This is first I'll tell you the variables. This is year, so that this data is from 1947 to 2021. Okay, this is life expectancy.
Ma'am, we are
Yes, Monica ma'am.
नहीं ठीक है. I'm not able to see the Excel sheet, but it's okay. It's okay.
Okay, others are able to see my screen, the Excel sheet?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. Okay, all right. So the variable is life expectancy, total fertility rate, infant mortality rate, and under 5 mortality rate. So my specialization is health sector, so that's why I took this variable. So you can take your own variables, that is not an issue here. Like we are here to learn the basically technique, right? Okay, so for example, I want to know the descriptive statistics of this series, life expectancy, right? So what I'll do, I'll go to this data analysis. Okay, then there is this option of descriptive statistics, this one, descriptive statistics. Okay, then I'll say okay, right? So under data analysis, I repeat the step. Under data analysis, I'll repeat this. And if you click on data analysis, this tab will be there in front of you. Okay, so under this, you click on descriptive statistics and then click on OK. Now this box will be there in front of you. Now this box is asking you input range, right? Grouped by, labels in first row, output options. Okay, all these things are there. So in input rate, for example, now I want to know the descriptive statistics of this series, life expectancy. I want to know what is the maximum life expectancy, what is the minimum life expectancy, what is the average life expectancy, right? What is the median life expectancy, how much skewness is there, how much kurtosis is there, all these things I want to know, or how many counts are there for this. Okay, and I want this data in grouped by columns. You can also tick on rows if you want it row wise, right? I want it by columns, right? Now this thing, labels in first row. So as I have selected life expectancy as well, this is my label, right? So I'll click on this. Yes, I have added labels in first row. If you have selected data from 40.1, if you have not selected label life expectancy, then no need to click this option, right? But here I have selected the whole series including the label, so that's why I have ticked here. Now output options, whether you want here itself. Okay, so for example, I want my descriptive statistics in this box, or you want this create a new sheet within the same Excel file, within the same Excel workbook, then you can click on this option, right? If you want to create all together a new Excel workbook, then you can click on this. But here for the time being, I'm clicking on this and I have selected this option for my output range. Okay, now I want summary statistics. So I'll click on this only, summary statistics, and then okay. All right, now Excel will create column wise descriptive statistics of my variable life expectancy like this. Yes, I have shared this file. Satbirji, I have shared this file on the WhatsApp group as well as here in the chat box. Okay, right? So here what I have got. Now the results are important, but the interpretation is equally important. Please explain once again, ma'am. Okay, so I'll do it once again. All right, you go to data analysis, this option. So when you click on data analysis, there is this box in front of you, descriptive statistics, right? Click on descriptive statistics and then click on OK, right? Okay. Now, like you select under input range that series, for that series you want the descriptive statistics. Now I want the descriptive statistics of life expectancy. All right, so if you want to know the descriptive statistics of maybe infant mortality rate, okay, or you want the descriptive statistics of under 5 mortality rate, so that depends on your, okay. All right, so this is your input range. So you select from the first column, from life expectancy till end, as I have did. B1 is life expectancy, B76 is the last. Okay, then click on column, then click on labels, and then select the output range, wherever you want your results. Okay, so I have selected this box, G2. This is G1, G2. This column I have selected, and click on summary statistics. Then click on OK. If you click on OK, you will get this. Okay, all right. Clear?
Yes, ma'am, got this. Yeah.
Got it, no? Now, this is your results, right? But you need to know how to do the interpretation of it. For that, you need to know the basic statistics, right? So you should know what do you mean by mean. Mean is average, right? So here, this 56.3, what it is representing? It is saying that the average life expectancy in India from 1947 to 2021 is 56 years. All right. Okay, like this you do the interpretation. Okay, then you should know like what do you mean by median. Okay, what do you mean by skewness, or like this minimum and maximum value. Minimum value is minimum life expectancy for the duration of 1947 to 2021 is 40 years. So 40 years is your minimum life expectancy, right? Similarly, 71.2. So 71 years is your maximum life expectancy. So in India, maximum life expectancy during this period is 71, right? And this is the sum of the life expectancy for this duration, and there are 75 count. Okay, 75 count. 75 years from 47 to this. Okay, so this is how you do the interpretation. This is how you do the interpretation. But like here, like we are not here to teach you basic statistics, right? Here we are working on the advanced research methods, and I'm here to teach you how to perform statistical analysis in Excel, right? So still I'm briefing you like what does it mean, how does it work, right? So that it would be fruitful for you. But later you please study about all these variables. What is the function? What is the idea behind calculating these variables? Okay. So any doubt in descriptive statistics, any of you? Please let me know.
No, ma'am.
No?
No.
All right. Okay. So if no, then take a 5 minutes or 2 minutes and calculate the descriptive statistics of IMR. Can you do that? Please do this and give me the average infant mortality rate, please. Take a minute and please solve this. So please let me know the average infant mortality rate in India from 1947 to 2021. Yes. So average infant mortality is 106. So all of you are with me on this?
Yes, ma'am.
Yes? Okay. All right. Okay. Next, I'll tell you how to calculate correlation. Okay. What do you mean by correlation? Okay. What do you mean by correlation? So can any of you answer me? What do you mean by correlation? Why do we calculate correlation? Any of you?
Ma'am, correlation is simply association of any two,
relationship between the two
yeah,
variables,
two
right?
variables. Yes,
So
yes.
whenever you answer, just answer in the correct terminology, right? So association between anything, this is a very generic way, right? Like if you're explaining to a layman, but like for your thesis, for your synopsis, you need to use the correct terms. Okay, so selection of words are important when you are explaining anything. Okay, so correlation is the relationship between any variables, any two variables, any three variables, like depends on your model, right? Or your data set. All right, so how do we do that? So if you click on data analysis, okay, data analysis, if you click on this, there is this option correlation. All right, under data analysis only, first we worked on descriptive statistics, next is on correlation. Okay, so if you select this correlation and click on OK, okay, so it will ask you about the input range. Okay, it will ask you about the input range. All right, so in input range, it is up to you, like among what all variables you want to check the correlation. Now here I want to see the correlation between all these variables. Okay, so I will select with labels, because here it is written labels in first row. If it is not written labels in labels option is not there in any of the tab, then do not select labels, right? Then select only data points. Okay, but here it is, this label is given, so I'm selecting, I want to know the correlation between all these variables. Okay, so I'm selecting this. So I have selected my input range from B1 to E76, right? Now I want this thing to be grouped by column. You can play around with all these things. Okay, you can select row and then check how the result output look like. Okay, then tick on labels in first row. Okay, now output range. Now output range I do not want here. I am exploring the second option, for example, because I have already did descriptive statistics using this option. So I want this new worksheet ply, and you can give this sheet name. Okay, name as results correlation. All right, then click on OK. So now what you have got here, now new sheet is open in front of you with the name of result score, right? Okay, and it is giving you this correlation. Now this correlation thing is there. Now results are there. As I said, interpretation is important. If you do not know what you mean by correlation, how to do the interpretation of result, then there is a no point of learning how to get it, right? So for example, here I'll brief you little. Life expectancy and life expectancy. One. Okay, so what is the range of correlation? Can anyone tell me? Range of correlation.
+1 to -1?
Yes, -1 to +1. It is not 0 to 1, right? Because there is a negative correlation, zero correlation, positive correlation. Okay, so three points are there. So -1 to 1 is the correct range of correlation. All right, so see, life expectancy, there is a one correlation, positive, because these two are same variable. Now, if you want to know about the correlation between life expectancy and infant mortality rate, so it is saying there is a negative correlation and very high correlation, 99%. Okay, so 99% correlation is between infant mortality rate and life expectancy. So this means that change in infant mortality rate has a huge impact on life expectancy, as there is a 19, they are 99% correlated, but negatively. Negatively means if you decrease the infant mortality rate, then you can increase the life expectancy. They are inversely related. Okay, because there is a negative correlation. If we speak from the economics point of view, price and quantity demanded, law of demand, that is negatively correlated. So if you check the relationship between price and quantity demanded, right, you will see that you will get the negative correlation. All right, negative correlation. Okay, so yeah, like we can provide insights later because this is not the actual data and we are not working on insights here, but the interpretation is important. Yes, based on your interpretation and results, you can provide suggestions or the recommendation in your thesis. Okay, but first you need to know what do you mean by correlation, how to calculate correlation, how can we do the interpretation of results, right? Clear? Okay. Similarly, you can check for under 5 mortality rate or total fertility rate. So there is a positive correlation between these two variables, right? So you can check for your variables. Now here I want to tell you one more thing, how to do the conditional formatting of this data. Okay, how to add colors to make it more prominent, because visualization is important whenever you are presenting any data set. All right, so so what you can do, you can select this table. Okay, go to home. Okay, first tell me, is this clear? How did I get this? Any question on this? Any question on this? Please tell me. Clear. For others, Komal, Tanima, is this clear? Or should I repeat?
Yes, ma'am.
Clear?
Yes.
Komal, is this clear?
Yes, ma'am.
Okay. All right. Okay, so
Thank you,
now
ma'am.
I'll tell you the conditional formatting so that it would look good. So select this table, then go to home option, home, and there it is conditional formatting. Okay. So under conditional formatting, if you click, there is an option of new rule, right? So if you click on new rule, all of you, please be with me. If you're not with me, I can repeat this step. Okay, so first select this. Agar select nahi karoge, it will not work. First select this, go to home, go to conditional formatting, go to new rule. Okay. All right. Next, you need to keep this like this only. Now change in format style. Add 3 colors, 3 color scale. Okay. So click on 3 color scale. Then minimum value, click on number because we are using number. Number are minimum value because range of correlation, as I said, -1. Okay. And I am giving it red color. Clear till now? Okay. Then for midpoint, for midpoint, click on number again. Our second range is 0. For 0, I'm selecting white color. Okay. Then for maximum, click on number, and maximum is our 1, right? Because range is from -1 to 1. Here I'll select this blue color. Okay. So you need to select on 3 color scale. Under minimum, midpoint, maximum, select number. For values -1, 0, 1, then red, white, blue. You can take any color of your choice. If you want green or red, you can use that as well, as per your interest. Okay. Click on OK. So see now. So this matrix look really good if you work on like more variables. Okay, and color differentiation is also visible. For example, I have created one here like this. See, so here for more variables, if you use this conditional formatting, it is like this. So you can easily identify where is the lowest correlation. For example, lightest pink, for example, here, lowest correlation between health expenditure and total fertility rate. Okay, or lowest expenditure is this, lowest correlation is this, mobile user and total fertility rate. See, okay, or you can say variables that are highly correlated. So blue, darkest blue, for example, this under 5 mortality rate and infant mortality rate, these are highly correlated. Okay, then this sanitation facility and infant mortality rate, these are highly correlated. All right, so this is how you can create a correlation matrix with conditional formatting, right? So now if you present this result in your thesis, in your research paper, right, for your data analysis, so or in your PPT presentation for your PhD viva, for your final viva, for your synopsis, so this will create a huge impact on the listeners, that you know what is the idea behind this, and your presentation is also good. Okay, right? So is this clear? Any question? Any question?
No, it's clear.
It's
No,
clear.
ma'am.
Clear.
Yes, ma'am.
So
Yes, ma'am.
please take 2 minutes and on exercise data. This exercise data, open this exercise data sheet and please create a correlation matrix of all these variables and generate a new worksheet, not the new workbook, worksheet. Worksheet means sheet within this workbook. New workbook means altogether new workbook. So please create a sheet here with correlation result. Clear? The question is clear? With conditional formatting I want, and send me screenshot on the group, please. Take 5 minutes and work on this. And if you have any question, how did you get the individual components? Individual components, Satbir, what are you talking about? Where? In the result file?
In the previous file, you gave the breakup of the parameter.
This one?
Yeah, the TFR, IMR,
Yes.
U5MR. So
Yeah.
you gave the breakup of on the in column A.
Yes, in column A, see, these are the variables. No, this is explaining you correlation.
Right.
That we have got it by using
But
that
how did you
option.
get how did you get more numbers of variables in column A?
No. This is do not get confused, please. This is what I have generated using this data file, right? The data this is given. Okay, while
Okay, ma'am.
this thing I have generated using sheet 1.
Okay.
That is not there. Okay, so do not get confused
Okay,
with these variables. I just wanted to know, like, show you if you add more variables. Understood? No, right? This is the idea. Okay, so you please create
I thought it was the same.
No. This is a separate data sheet. So please create a correlation matrix.
Ma'am, do we need to, while selecting the range, do we need to select from the first row or only data points?
No, you need to, because obviously you want the name of this thing. No, if you want this label's name, right?
Yes.
Definitely you want these labels name. So select from the label and tick on label as row variable.
Okay.
There is this option under correlation. Okay.
Nice,
So tick
nice.
on labels tick. Okay. So all of you please work on this exercise data and create correlation matrix with conditional formatting. Take 5 minutes and send me screenshot. Then we'll go ahead. And one suggestion here, when you select colors, okay, so select the colors for that color, lighter shade is visible or not. Okay, right? So for example, lighter shade should be available for that color to show the lower correlation and high correlation. Okay, so that's why selection of color is also important when you are using this thing. Right, so this is how you calculate correlation and how you add conditional formatting. Any question, anyone, on descriptive statistics, on correlation, the steps, anything, tool pack installation? Any question, anyone? Please tell me. So color combination is also important, right? For example, if you will select green and red, green and pink, it is not appealing that much. Okay, so blue and pink goes side by side, yellow and green will go together, right? So when you are using colors, just make sure that you are using the right combination to make the graph appealing. Okay, all right. Okay, should I wait or should I move on to the next topic? Please tell me. Yeah, Pooja Prasad, you have selected good colors. Graph is appealing. Okay, 1 more minute. Please send me fast. So what about others? Swati Parmar, Grisham Tripathi, Pradeep Mehta. I have not received your screenshots. Mamta Dabas, Gurpreet Kaur, Priyanka Yadav, Kirti Dahiya, Kaveri, Siddhika Mohan, Priyadarshini, Komal Sharma, Alicia, all of you, please work on this. Mitali Shah, Anjani.
Yes, ma'am, will send, ma'am.
Okay. All right. So now we have covered descriptive statistics and next is correlation. Next, I want to show you histogram before moving to the regression part, right? So histogram, you must have covered many data chart yesterday, like scatter plot, maybe bar chart, line chart, right? So today we will learn histogram. Okay, so what is the prerequisite for histogram? You need frequency table. Okay, because histogram based on the class interval, so you need frequency table. So first we will create frequency table based on this. For example, I want to create histogram for life expectancy indicator. Okay, so what I'll see here, my minimum is 40, right? Maximum is 71. Okay, so how would I create my this thing intervals? For example, I'll write here life expectancy. Okay, life expectancy. Now I want to know between, say, 40 to 50, between 50 to 60 years, then 60 to 70, then 70 and above. Clear? So for histogram, first requirement is to create intervals, because here this is not continuous data, this is discrete data, right? And histogram is possible in this. So from descriptive statistics, we have analyzed that minimum life expectancy is 40 years, maximum is 71. So on the basis of this, I have created this, like how many people are there in between 40 to 50. How many are there between 50 to 60, or in how many years? People is not here as a variable, years. So in how many years? Okay, 50 to 40 to 50 life expectancy was there, or in how many years? 50 to 60 years life expectancy was there. Okay, so next is we will create here lower bin and upper bin. Okay, so for example, here lower is 40, upper is 50. Lower is 50, upper is 60. Okay, or what you can do, you can add one this row here, 0 to 40 as well. Okay, so if 0 to 40 is there, your lower bin is 0, upper bin is 40, like this. Okay, so do not think if 0 is there, what should we do? Write a 0 in the lower bin, then 60, 70, then 70, and keep it like this. Okay, because 70 above, we don't know the highest figure. All right, now
Vani
is this
ma'am,
clear?
in life
Yes.
expectancy, like in the second row, do we put 51 or we put 50 only? 40 to 50.
Yes, 40 to 50, 50 exact is still there in the first interval.
Okay, then,
If it is 50.1,
then it will come in the
50.1,
second one. Okay.
second one. This is the rule. Okay, this is the rule. All right. Okay, so everybody is with me on this. Any question? How to create frequency table? How to create this? Should I repeat, or is this clear to all? Please like either unmute yourself, speak, or type it in the chat box.
Clear, ma'am.
Clear?
It's okay, ma'am. It's okay.
Yes, ma'am.
Clear, okay, perfect. Right. So next is what we will do. We'll go to the same data analysis. Clear. Okay. Same this thing. Go to data, then data analysis. Under data analysis, there is histogram. Okay, histogram, click on OK. Right? Histogram is there. Now input range. What is your input range? So now see labels are here. So select label as well. So this is my input range, right? I'm working on life expectancy. If you're working on IMR, you can click that. If you're working on under 5 mortality rate, you can work on this. But I'm working on life expectancy. So I'll click this. This is my input range. This is my input range. Now bin range. Always remember that in bin range, you will add upper bin. Okay, you will add upper bin, not lower bin. Where is my upper bin? This one. Always remember this. Okay, no need to add this, to just add upper bin. All right, then click on labels. Okay, select output range. I want it on the same sheet. So I'm selecting this as my this. Okay, now I want chart output. Okay, so input range is your variable, bin range is upper bin, and click on label, then output range, then chart output. Click on OK. Okay, so this is your histogram, right? You can shift this table here. Okay, you can shift the histogram here, right? So if you click on the question, so okay, so if you click on this histogram, go to chart design, right? If you click on this, under chart design, you can format this. For example, if I want this, because here data labels are also there. Okay, so for this category 25, okay, for this category 21, for 21 years, 70 years life expectancy in India was for 24 years between this duration, like this. Okay, so this is how you create histogram. Now it depends on your data set, what data set you have, right? You create upper bin, you create now for example, for this IMR, for example, I want to know the histogram. So what you will do, you create descriptive statistics or calculate minimum maximum value and create intervals, lower bin, upper bin, then go to data analysis, histogram, and click on add input range, labels, and then chart output. Okay, and then you can use any type of this thing you want for your histogram. Okay, so any type you can want, maybe like this, you want this, so that you can select from chart design, whatever is your requirement. Clear? So, but interpretation is important, as I said, right? So how do you interpret the histogram? Okay, so how do you do the interpretation? You say that for the 50 or below, right? Okay, like this, because 0 is not here. Now, for example, if I'll create this thing again with 0. Okay, so for 0 to 40, for example, and then I'll write this. Okay, so lower bin is 0, upper bin is 40, right? Now I'll create histogram. For input range is same, bin range is different now. Bin range is this. Okay, label output range is different. For example, I'll say this is my output range. Okay. So see, now this is my histogram. Okay, so for 0 to 40, if you see, no bar is there. So what it is representing, as I said, there is minimum is 40, no? So that's why for 0 to 40, there is no bar. Okay, right? 40 to 50, this thing is there. So you can use where data labels are there. Okay, right? Then for 60, 50 to 60, this much, and 70, 60 to 70 is this much. Life expectancy, yes, that's why under 40, no, there is no bar. Okay, right? So this is the interpretation, but to be specific on interpretation, you read to more about the histogram. All right, okay, right? So this is how you, later you can delete this also if you do not want this. For example, I do not want this. I do not want all these things. Delete. Okay, just delete this. Okay, so what I'm doing, I'm keeping this and
Madam, this
this.
table upper bin frequency, it comes automatically or you
Yeah, this
read it?
upper this frequency table, no, it comes automatically if you build up a histogram.
Okay,
Okay,
ma'am.
you will get this automatically.
Okay,
Okay.
ma'am. Thank you.
Yeah. Okay, right. So maybe you can show this area as like this thick border. You can remove, say for example, you want to remove grid lines. So click on view. This box is view. View. You want to add grid lines, remove grid lines. Okay, like this. So that's how you can do the formatting of your stuff. Okay, so for example, I want to add grid lines, remove grid lines. So you can explore the features there in Excel, right? The main objective is to teach you how to draw histogram, and this frequency table is automatically generated. You can write here also frequency table. Clear? Now, can you create this histogram?
Ma'am, do we
For
need to create this table of upper bin and lower bin?
yes, yes,
Is it required
yes,
or it cannot come
yes,
automatically?
yes. No. Upper bin and lower bin figure will not come automatically. Okay, because I have created this. And for histogram also under bin range, what will you put
Okay.
under bin range?
So it is tailor-made by individuals.
Yes, there might be some shortcut, but I don't know about this.
Okay.
Like you can check, but according to me, you need to create this. There is no
Okay.
shortcut for
Okay.
this, but you can explore this if there is any shortcut for this or no. So right,
Okay, ma'am.
but
Understood.
this is auto generated. This you need to create yourself.
Okay.
Okay.
Thank you.
For your data, because sometimes you need different range, different, so that depends on your requirement.
Okay.
All right.
Thank you.
Any question, anyone? Now please create histogram for IMR. As you have descriptive statistics, please create, take 5 minutes and create histogram for IMR, please. Working on the data set, yes. No, Tanima, why it is 50, 60, and 70 you have created for IMR? Is this the correct interval? What is the maximum and minimum of infant mortality rate?
Yes, ma'am, I'm changing it.
Yeah. First calculate descriptive statistics and then do the correct.
Ma'am, for selecting the bin range and input range, how should we go about that, ma'am? What is input range and what is bin range?
Okay, so input range is your variable range, life expectancy, like infant mortality rate if you are taking. So select the IMR range, IMR
Okay,
data.
in the column of the IMR.
Okay, yes, IMR from
data.
IMR.
Okay, ma'am.
Yes,
And
bin
in
range.
case,
in bin range, you select the upper bin, the one you have created, no lower bin, upper bin. Select the upper bin, including upper bin label. Okay, so that you can tick on label. All right.
Okay. Understood.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, I'm able to do it till upper bin frequency, but for diagram for this chart, where to get this chart? Histogram?
Go to data analysis. Under data analysis, histogram option is there.
No, I did this all data analysis and I got this upper bin frequency.
Yes. You have created this table, right? Lower bin, upper bin. Yes.
Yes, I have created the table.
Now.
Then I click the output range and all.
Yes.
Then I'm not getting the diagram, this graph, histogram graph, but I'm getting.
Did you click on chart output? Yes.
Yes.
Can you share? Can you share your screen?
Yes, sure.
Okay, I'll stop sharing.
This one.
You please redo this. Go to data analysis. Data analysis.
Histogram.
Okay, yes.
Okay, input range this.
What you have selected, D1.
IMR.
Okay, what is your bin range? Show me. It's Q.
It's 20 to 50, 50 to 100, 100 to 150.
No, you have CCC. Here, what is the problem? You have selected wrong upper bin, lower bin range. See, your lower is 20, 50, 100 and 150. 150, no, lower bin. Last figure should be 150, 150 to 200 you have created interval.
Oh.
Right? So just correct this thing.
This one should be
200.
200.
This one should be 150. Lower bin should be 150. Okay.
50.
Okay. Yeah. What is your, okay, right, okay. Chart output you have not clicked. No, last option, chart output.
Okay.
Yes. Now, okay. Okay.
So I'll try to redo this once again.
Just click on OK. Maybe you will get histogram at least. Maybe. See, histogram is there. There is some data issue. Otherwise, right?
Okay. Thank you, ma'am. Ma'am, sharing has been stopped.
Please stop the sharing. Right? You can work on this. Right, this is okay. Yes, this is fine. If you have received the histogram and the frequency table, right? All right, I guess. Now, please stop sharing your screen. Yes, yes, Komal, any question?
No, I'm saying I just completed that.
You have completed?
Yes, yes.
Or it is, yes, no. So should I go ahead on regression?
Yes, please. Yes, please. Yes.
Okay. Okay, all right.
Do you have any suggestion for the number of columns in the histogram for better visibility? Because if the number of columns or sticks in the histogram are more, then it may be more confusing. Is there any suggestion from research point of view?
So see, the idea is like if you have a more data set, right, large data set, you can reduce the interval and reduce the bars. It is up to you, like how much bars do you need, right? For example, maybe like you want smaller bars, right, for longer time period. So it depends on the requirement of your client or your research guide, right, or your like publisher. Okay, which format do they want? If they want smaller chart, right, then you can keep less bars by reducing the class interval, by increasing the class interval. For example, you create class interval from 40 to 70 like this, so you will get only one bar. Okay, so this is the idea. So it is up to you. There is a no like thumb rule for like how many bars should be there in histogram. It is not fixed. It depends all on your data set, right?
Okay. Nice.
Right. And colors also depends on like if your client say yes, these colors you should use. For example, for life expectancy, generally we use green color. For mortality rate, generally we use red color, right? So then you are bound to use those colors only. Otherwise, if it is up to you, like which colors you should use so that your graph would look attractive. Yeah. Okay, so this is how it works. All right. So okay. So I'm expecting that everybody is with me on this. They know how to calculate descriptive statistics, how to do the interpretation of result, right? Second, how to do calculate correlation metrics with conditional formatting, right? Third is your frequency table and histogram. Clear? I hope
Ma'am,
everybody is.
regarding
Yes.
levels of the x-axis and the y-axis, how it is obtained in histogram? Do we have to insert it or
The levels.
labels?
Labels, data labels, that you can right click and do the formatting, add data points, add the trend line, that you can do.
For example, Gitika ma'am has given the histogram with frequency on the x-axis written on it and upper being written on the
That under
x-axis.
chart design, there are options. So
Okay.
you can select as per your choice. So she has selected this one, right?
Okay.
So you can select as per your choice. There are 10 or 15 chart designs. So under some chart design, black is there. Under some chart design, data labels are included, right? And after that chart design also, if you right click and do formatting, you can do format as per your interest.
Okay.
Okay, so first click on chart, then only chart design option is there. If you do not click on histogram, chart design option will not be visible to you. Okay.
Okay.
Clear?
Thank you.
Okay. All right. So now next we are moving to regression. Any question, anyone? Please, last call for questions. Even a silly questions I'll answer. Please tell me if any
Ma'am,
question,
I
anyone.
shared the new histogram.
A new histogram you have shared. Okay.
Yes,
On
the
WhatsApp?
corrected one.
Okay.
Yes.
The edited one. Okay. All right. Okay. Okay. And I'm expecting that you should know the interpretation of this graph as
Yes,
well, right? If you do not, then please read more on this. Okay.
Oh.
Okay. So now move on to regression. What is regression? First question. What do you mean by regression? Tell me, what do you mean by regression? Any of you?
Ma'am, regression refers to a statistical technique that relate a dependent variable to one or more independent variables.
What is the difference between correlation and regression? Tell me. Anyone? No. So correlation is basically explains you the relationship between two variables.
Regression helps us to predict.
Yeah, to estimate. Yes, to predict, to estimate the relationship between two or more variables, or we can say dependent or independent variable, or we can say relationship with the response or target, that is your dependent variable. Okay, so regression is basically to estimate, to predict, to estimate the relationship between two variables, while correlation is not to estimate but to check the relationship is there or not. In regression, we do the estimation thing. Okay, so this is the main difference, right? Okay, now I will share the sheet, relationship strengthened between variables. Okay, let me share my screen. Okay, right. So next, we should know like the regression equation. Anybody work on regression little bit? There are two variables, just to brief you on like background of the regression so that you will understand it in a better way. So if you say y equals to a plus bx or a minus bx, so this plus and minus depends on the relationship between x and y that we have currently checked in correlation, right? So if my x and y are, say, if my x and y are infant mortality rate and life expectancy. See, if my y is life expectancy, x is this, then the equation would be y equals to a minus bx, right? But if my dependent variable is total fertility rate, right, then my regression equation would be y equals to a plus bx. So this is plus and minus difference, right? Now X is your independent variable, Y is your dependent variable. Dependent variable, target variable, response variable, right? While independent variable is also has certain synonyms, like we can say explanatory variable or predictor, right? Okay, this is how it works. So first, what we need to do, first we will create a scatter plot between the variables to see the relationship between variables, if they are linearly related, not related. Okay, right? So what is the difference between simple linear regression and multiple linear regression? In simple linear regression, we take two variables, okay, X and Y, dependent and one independent variable, univariate analysis or bivariate analysis we do, right? In simple linear regression model. While in multiple linear regression model, we will take multiple independent variables, okay, that might be linearly related or non-linearly related, okay, while in simple linear regression they are linearly related. Okay, clear? Okay, so first what we do, we plot the scatter plot. Okay, for example this, so here I'm say, now for example I do not want TFR, or I'm considering, so this is I'm considering the case of multiple linear regression. So yeah, step number one is to identify your variables, which one is your dependent, which one is your independent variable. Okay, the step number one for regression, right? So here I'm saying this is my dependent variable, this is Y variable, others are my, this is X1, X2, X3, these three are my independent variable. Okay, right? Okay, so what I'm doing, I'll draw a scatter plot. Now you know how to draw a scatter plot. Go to insert, right? There are two ways to draw a scatter plot. This, you can click on this scatter plot and the first one. So it is giving you some results. Okay, some results it is giving you. For example, this TFR, this, right? So there are three variables and here one is dependent variable. So they are negatively related like this. Okay, some option it is giving. This is one way. Otherwise, how you can create a scatter plot, one more type is there. You just select this first one, blank scatter plot. For example, I'll do for this, for example. Okay, so what you can do, you do not select any data, just go there and select it. Okay, then if you click on this, you go to select data, right? So under select data, you click on add, right? So you can add X value, Y value. Okay, so for X value, maybe I want these as my X values, right? For Y values, maybe I want this as my Y value. Okay, then you can click on OK. Okay, right? So now it is showing you linearly related. These variables are linearly related. Okay, like this. See, pattern is there. Or what you can do, you can add, if you right click on this, add data labels, add trend line. If you add regression line, if you click on add trend line, then you will get the following features. Okay, so you click on linear and then you click on display equation on chart, display R squared value on chart. Okay, display equation on chart, display R square value on chart. Okay, then close it. Now you have regression equation with you and R square. Right, what is R square? You should know. Right, so this is your regression equation. They are linearly related. Okay, So for this is for the scatter plot, for example. So this is the common one that that is for a layman we can use, right? Okay, this is one thing. You can draw the scatter plot, you can visualize the data. Okay, then you can go for regression thing. Okay, all right. Now second is how to linear regression. Yes, linear regression. So then you go to data, right? How do you calculate the regression results in Excel? This is what we are learning here. Okay, go to data, then go to data analysis. Data analysis. Under data analysis, there is a term called regression. Okay, regression is there. Click on OK. Right? So if you go to data analysis, it has regression, right? This box will be there in front of you. Now what you want? So that's why I said the first step is to identify your variable. Which variable you want to keep as Y, what all variables you want to keep for X, right? Okay. So now for example, Y, I am taking this one, life expectancy. Okay, right? Now for X range. Now for X range, it is up to you. You want one variable, two variable, three variable, right? So here I am using X range IMR and under 5 mortality rate. I am not using total fertility rate. Okay. So under X range, I am selecting these two data series. Yeah. You select Y, you select X. Then click on labels. So under Y range, I have selected my life expectancy. Under X range, I have taken two data series. I have left TFR. I'm not interested in TFR. I'm interested in infant mortality rate and under 5 mortality rate. Okay. So I have selected these two range, and as I have selected the variable name, so I have ticked there under label option. Okay. Now it is up to you what confidence interval you want to select. As 95% confidence interval is the standard. So confidence interval means how much there is a probability that you are getting this. So if 95% means there is a 95% chances that this will happen. Okay, right? You can select 99 confidence interval also like this, or you can select 90 also, right? But I am taking it there, the general one, not selecting confidence interval, the standard one, 95%. Clear? Now output range, I can go here only on the same sheet, but I want new worksheet because here so many histograms and everything is there. So new worksheet, I can write regression. Okay. Right. Now you can click on residuals. If you want residuals, you can click on line fit floors. You can play around with all these variables and check what other options are there. Okay, so for the time being, we are doing this. Tick on residuals, tick on line fit plots, and tick on normal probability plots. Till now, it is clear?
Yes, ma'am.
Okay, right? Then click on OK. Right? So if you click on OK, you will get this summary output. Summary output for your data set. Right? This is how you calculate or do regression analysis of any data set in Excel. Okay, this is the working part, right? Calculation part. Now the important part is interpretation. Okay, how do you interpret your data? Yes, everybody is with me on this. R square. Yeah. So we'll do the interpretation now. Please, others also say if this is okay. Are you with me on this or no?
Yes, ma'am.
Yes. Everybody got this summary output?
Yes, ma'am.
Yes, okay. Right. So this is how you calculate regression analysis in Excel. Now, what all terms is here? What do you mean by multiple R? Any of you? What do you mean by multiple R? Explanation by all variables. No. What is multiple R? This term multiple R. Any of you please think and answer me. When we study more than two variables. No. If you study two variables, then also you will get this multiple R in the summary output. Correlation between independent and all dependent variables. Dependent variable is only one dependent variable. All independent variables and dependent variable. Okay, right? So this is basically coefficient of correlation, multiple R. Multiple R is your coefficient of correlation, right? Coefficient of correlation. Like when we do it manually, we say Carl Pearson coefficient of correlation. या एक और होता है ना, दो methods we used to study in your graduation or post graduation to calculate coefficient of correlation. So here in the summary output of regression analysis, this multiple R says your coefficient of correlation. So if your coefficient of correlation is high, this generates problem of multicollinearity in your model. Okay, so when you will study econometrics, you will learn these 3-4 terms: stationarity, autocorrelation, heteroscedasticity, and multicollinearity. Okay, so the values here, which is given here, this has a direct impact on your classical linear regression model assumptions, CLRM, classical linear regression model assumptions, that says there should be no autocorrelation in your data. There should be no multicollinearity in your data. There should be no heteroscedasticity in your data. Right? And higher the correlation coefficients implies that there is a problem of multicollinearity in your data that you need to check. Now there are different tests to check that multicollinearity. Okay, that it is possible only in SPS, is another statistical software, because here there is a no option to check autocorrelation multicollinearity. Clear? Okay, so this multiple R says your coefficient of correlation. Now, so this range is, as we discussed, this range is from -1 to 1. Okay, so here it is positive. 99% we are saying the variables are correlated. Okay, strong relationship is there between the variables. What are the variables? Life expectancy, infant mortality rate, and under 5 mortality rate. Okay, right? So they are highly correlated. So this model is not a good model if it leads to a problem of multicollinearity. So this is not the only indicator that says there is a multicollinearity. There might be the case where you run the multicollinearity test and it says there is a no multicollinearity in the data, right? So this variable do not hire the figure, does not judge, but this might be one reason for multicollinearity. Okay. The next indicator is your R square. Now, what is R square? What is R square? Tell me. Any of you, what is this R square? Coefficient, no. Kaveri, coefficient of correlation, I just said this is multiple R is your coefficient of correlation. What is R square? This next variable, this one. This one, what is R square? Coefficient of determination. Yes, coefficient of determination, right? Is it explains how much variations are explained by the model, right? Okay, so higher the R square, good for the model, but it is not always correct that if your R square is higher, it means your model is good or perfect. No, we always check for CLRM assumptions. Please read more on this. Okay, CLRM assumptions. No, it is not regression model. It is coefficient of determination. So coefficient of determination, it says basically it use as an indicator for goodness of your model. Okay, right? So if here it is 98. So we can do the interpretation like this, that 98% of variation in dependent variable is explained by independent variables. So this is a good model. There might be a case where you get R square as 40%, 0.40, right? So you can say only 40% variations in dependent variable is explained by independent variable, right? But if you look at the positive side, if say 45%, 0.45 is R square, then you can say half of the variation in the dependent variable is explained by independent variable. Okay, right? Right? Am I clear? Am I audible?
Yes, ma'am.
Yes, no? Okay. So this is how you do the interpretation. So it is not always necessary that 98% it means your model is perfect. No, you need to check for other assumptions. You need to check for p-value, right? Okay, but this is one of the indicator for the good model that your R square should be higher, but we do not reject the model that has a lower R square, say 40%, 45%, because we look at the positive side, being an economist, being a statistician, right? We look that, okay, 45%, like half of the variations are explained, so model is still doing good. Okay, so that is up to you, how you do the interpretation. So this is your coefficient of determination. Okay, now there are two terms here, R square and adjusted R square, right? So what is the difference between these two? So this is basically your R square that is adjusted for the number of independent variables. Okay. For example, if higher the independent variables, for example, if I have 4 or 5 independent variables for my model, right? So we should always look for adjusted R square. If you will see adjusted R square, you will find always less than R square. Okay, why here also even if it is very minorly like less than this, it is 226, it is 516, but adjusted R square is always less than R square. Why? Because this is the R square that is adjusted for the independent variables. Okay, so the best way is to take the adjusted R square instead of R square. The meaning is same. Adjusted R square is an adjusted coefficient of determination, right? So economists or statisticians consider adjusted R square for the interpretation of their model, right, to justify their model instead of R square, because based on your independent variable, this is adjusted. Clear? Okay, then a standard error is the goodness of fit measure, right? Okay, precision of like your regression analysis. Okay, so smaller the value, the more certain about your regression equation. Okay, so standard error, the less the standard error, it is best for the model. Okay, so absolute measure shows the like average distance. So if you draw a regression line, there are points that is above the regression line, below the regression line. So standard error, it says how much there is an error between the estimation and the actual. Okay, right? Then number of observations here, and you know that is 75 because we have taken the data for 75 years. So number of observation are 75. Okay, right? And then degree of freedom. Now this is sum of square. Okay, so sum of square is basically this like, so Excel split the sum of square between like this thing, two components, regression and residual, right? Okay, so it gives the information about the level of variability within your regression model. Okay, so smaller the sum of residual compared to the total SS. Okay, so here your total sum of square is 6178 and your sum of square of residual is 64. Okay, so it means your model is better. It has a better fit of your data, right? So this should be, residual sum of square should be always like lesser than this, the total
Can you
SS.
please repeat once again this table, ANOVA table, regression SS 611.
Yes, yes. See, so sum of square, total sum of square, right? Sum of square. Here you have for regression and for residual, right? So this represent basically goodness of fit or like better test for your model, better fit for your model. Okay, so your residual sum of square should be less, always less than your this things, total sum of square, right? So here it is less, it implies that your model fitting good. Okay, mean sum of square is nothing but your total sum of square divided by this. Okay, right? For example, if I'll do this, sum of square divided by degree of freedom. Okay, so this is your mean sum of square, average sum of square. This is nothing but sum of square divided by your degree of freedom. Okay, now what is F? F statistics basically test the overall significance of the model, whether your model is significant or not, overall significance of the model, right? Okay, now this significance F is basically the p value of F statistics. Okay, p value, if you know this rule of p value has 3 range. P value is like 2 range, basically less than 5% or greater than 5%. Why I am saying 5%? Because I have selected confidence interval 95. Okay, if I have selected the confidence interval 99, right, then my p value would be either greater than 1% or less than 1%. 1% means 0.01. Okay, right, 0.01. Or if I have considered the confidence interval 90, okay, so then p-value would be either greater than 10% or less than 10%. Okay, right? So p-value is greater than 0.10 or less than 0.10. Okay, so if p-value is, now here confidence interval is 95. So I'm taking p-value for the range of 5%. So if p-value is less than 5%, it means your model is significant. If it is greater than 5%, it is not significant, right? Okay, so here, is this significant or not significant? Tell me. Looking at this p-value of F statistics, is this significant or not significant or insignificant? Significant. Other answers, please. Significant or insignificant? Yes, it is significant. Why it is significant? Because it is 5.4126 E. I hope you know how to write this term. If E is there, it means it is 0.00000, like till 72. Okay, so it is less than 5%. So this is significant model. So this is the p-value of your F statistics. That's how you do the interpretation. So I'm not here to teach you statistics basically, okay, that you should know how it would work. So I'm just briefing you like little components, okay, how you do the interpretation, but you need to read more on this, okay, because if we will discuss here the interpretation part, then the working would be difficult. Okay, next is this table. Also I'll give you a brief about this table. Okay, so here what is given, now this ANOVA is clear. Okay, now if we, now as we know, the regression equation we say is y equals to a plus bx1 minus cx2. Okay, so I'm saying this is my regression equation, right? This is my regression equation I'm saying. Now, what is A here? X and Y are component, right? X and Y are, sorry, variables. Y is your dependent variable. X1 is your one independent variable. X2 is your second independent variable. What is A here? No. I do not need a figure. What is A? A is your intercept, right? A is your intercept. B is your slope, right? B is your slope. Or we can say B and C are your coefficients. B and C are your coefficients for X1 and X2 variables, right? So coefficients. So we look for this here, coefficients, right? So A is your 74. B, X1, because X1 I'm considering infant mortality rate. So this is your minus this thing. So it would be minus BX1. So B is your minus 0.028. So I'll write this here as Y equals to, this would be minus 0.028 X1. This is also minus, C is also minus, right? Is 0.0959.
You can add A value also, no, ma'am?
Yeah, A value also I can write, yes. So A value is 74.17, right? Okay, now these are your estimated coefficients. Now if you have studied statistics, these estimators should be blue. Best linear unbiased estimator, right? Okay, if you recall the theory, you can read more on this. Your estimator should be blue, best linear unbiased estimator. Okay, so here A is your intercept, B and C are your coefficients for the variable. Okay, if it is a two variable, then B is your slope, like this, like how much there is a change. Okay, how do you define slope? Tell me. Rate of change.
What is expression of blue?
Blue is best linear unbiased estimator.
Okay, thank you.
Okay, yeah, right. Okay, so here one more thing I want to add. If it is not significant, right, so it means your variables are not correct. Okay, you need to choose another variable. One more point I want to add here, right? Okay, now output of the coefficients, you know what is intercept, what is your B, what is your C. If there are other variables, you can know the coefficient, and their plus and minus sign is important. So this minus thing is saying that there is a negative relationship between life expectancy and infant mortality rate. It means if you reduce infant mortality rate, this will increase your life expectancy, right? Similarly for this, if you will reduce under 5 mortality rate, this will increase your life expectancy, right? If here it is not negative positive, then you can say if you increase under 5 mortality rate, this will increase your life expectancy, positive relation. But here we have your variables are inversely related. Clear? Okay. Right. Now the standard error, as I said, this T statistics P value. Now this is important because everybody is concerned about P value. Okay, now for P value, we need to check this, whether it is less than 5% or not. Because to reject null hypothesis, we need P value to be less than 5%. Okay, so to reject null hypothesis, P value should be less than 0.05. Sorry, 0.05. No, how come here is P value is this thing? See, IMR, P value is insignificant. It is greater than 0.5. It is 0.72. Right, so here P value is insignificant, right? P value is, just a second.
Ma'am, you're mute.
Yes. Okay, so P value is insignificant here. Okay, we are not rejecting null. Now, as you know, in hypothesis testing, I'm not explaining the process. You need to set up your null hypothesis. For example, here we have set up our null hypothesis that there is a no significant relationship between life expectancy and infant mortality rate. Okay, so this is the H note I have set up, and H1 is my that there is a significant relationship, right? there's a significant relationship. So I need to check p-value. Here p-value is greater than 5%. It is 0.72, right? It is 72%. It is not less than. So here we are not rejecting our null hypothesis. We are accepting, we are saying there is a no significant relationship between life expectancy and IMR. Similarly here, under 5 mortality rate, it is 0.06. It is not 0.05. Right? It is greater than 0.05. So here is also p-value insignificant. So we are saying there is a no significant relationship between life expectancy and under 5 mortality rate. Okay, so this is how we do the interpretation of p-value of your model. Okay, we check this and this specific for each variable, right? Maybe p-value is significant here. Okay, it could have come like this. Then we can say p-value is significant here, so we are rejecting null hypothesis. So there is a significant relationship between under 5 mortality rate and this thing, क्या बोलते हैं इसको, life expectancy. Okay, like this. So you always look for p-value, but that depends on your confidence interval. If you will select there, maybe if you have selected confidence interval, say 90 there. Okay, then we are saying now you need to look for p-value is whether greater than or less than to 0.10, 10%. Okay, 10%. Now if you look for this, then this is significant, है ना? पहले वाला value is also significant if it is there, because this is less than 10%. Okay, like this. So this is how you do the interpretation. This is very important, okay, because here I'm teaching you how to do regression analysis in Excel, but actual interpretation you need to learn. Okay, otherwise there is a no point. So this is how you do this. Okay, next is your residual output. Residual output. Okay, what does residual output gives you? So it gives you your observation, like how many observations are there, what is the predicted unit or predicted life expectancy, right? And what is the gap, residual error. Residual is basically to compare your estimated value and actual value, right? So how many like what the estimated life expectancy and what is the actual life expectancy. Okay, so the gap is there in between, that is your error, residual, right? Okay, so how far is that is what it explains. And then if we look for this thing, these line plots explains the relationship between IMR and life expectancy. It shows negatively related, see, inverse relationship you can see. Okay, and predicted, this is estimated life expectancy, so this is showing your negative relation, inverse relationship. Okay, so whenever you do any regression analysis, you should ask question to yourself. Question number 1, how much of the data does this explain model, right? How much of the data does this model explain? So where is the answer of this question? If I say how much of the data, adjusted R square. Okay, how much of the data does this model explain? So here I'm saying this one, 98% of the data this model is explaining. This is your question number 1. Okay, clear? Second question is this a good model? Is this a good model? So where in this summary output, which figure will explain is this a good model or not? Tell me.
P-value in ANOVA, F, significance.
In ANOVA, which value?
P-value.
P-value of F, this significance F.
Yes.
Okay, this will give me the second answer. Is this a good model? I'm saying yes, this is a good model. How this is a good model? Because p-value is significant here. The overall significance of the model is there. Okay, right? Because this is less than 5%. Okay, second question, this figure will answer. Third question, what is the relationship between dependent and independent variable? Tell me.
So in column B, we will see this sign of figure where if it is negative, then there is a negative relationship. If it is positive,
This multiple R will give you this answer. Okay, what is the relationship, or positive and negative? This thing, this is your coefficient of correlation. So this can be answered in two ways, this positive and negative. If this is positive relation between y and x. If negative, so this through this sign we can answer this question, what is the relationship between y and x? For example, I'm asking here, what is the relationship between life expectancy and infant mortality rate? You will answer, ma'am, it is negatively related. There is a negative relationship between infant mortality rate and life expectancy. Or if I'll ask you, what is the relationship between life expectancy and under 5 mortality rate? You will say, ma'am, there is a negative relationship between under 5 mortality and life expectancy. Okay, so this answers your third question, right? Fourth question is, do I have a good variable, or have I included good variables? Good variables means independent variables. Have I selected the relevant independent variables? Okay, so which figure would answer me that? Tell me.
Ma'am, these residuals, it should be less than the sum of square values for.
No. P value, this thing will answer me this question. Okay, so if this value,
what is the question?
The question was, do I have a good variable? So if this p value is significant, it means I have included good variable. If this p value is not significant, it means I have not included good variable. Okay, right? Okay, generally we say like this, but residual part is also like we can include that if error is less, sometimes we say if error is less, okay, then also we have included, but generally we look for this. So four important thing is in this part is, one is this, second is this, third is this, fourth is this, and fifth is this. Right? Yes.
In this case, can we say that the input variables or independent variables are not significant in this case?
So independent variable is not significant, it means I have not selected good variables because p value is not significant. I might need to change my variable. This model is not good.
Is it correct?
See, now interpretation is like this. Even if your R square is high, even if your F value is significant, even if everything is there, but if P value is not significant, your model is not. If model could be good, maybe you want to you do not want to reject your null hypothesis. This might be one reason. So we cannot say if p value, should always be p value should be less than this, but generally we look for significance. It is significant or not. Generally we do like this only in statistics. Okay, we reject the null hypothesis because p values are significant. It is like this. It works like this. Okay,
but going into deep of the matter, then we can say that the variables are not good enough for this case.
For this case, what are you saying? Please repeat your question. For this case?
For this case, because the p value of IMR and under 5 mortality rate, it is not a significant p value. So we can say that even though other parameters are okay, but selection of parameters, selection of variables, IMR and under 5 mortality rate are not good enough to explain this model.
Yes, exactly. This is what I'm saying. Okay, yeah. Right, so this is how you do the interpretation. There are so many variables in this that you need to identify. So your model is not dependent on one thing. It is dependent on so many things. So these 4 or 5 questions you should study. How much of the data does this model explain? Second, is this a good model? Third, what is the relationship between y and x variable? Or do I have selected good variable? Okay. Now I'm asking to you, does this make any sense to you? This is my question to you. Does this make any sense?
Yes, ma'am. Yes, for sure.
Yes.
For sure.
Okay. 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 Right. Okay. So now for hypothesis testing for regression model, the step number 1, if you know the basics, step number 1 is to build up your hypothesis, right? Identify your variables. Okay. Set up your null hypothesis, alternate hypothesis. So when you have everything, then you run your data. It is not like that you have not built up your hypothesis. First you are getting the result, then you are building up your hypothesis based on the results. No, it shouldn't work like that, right? Okay, now this is the basic regression thing. But if we talk about the higher version of this, you're working on time series model, econometrics, then you check the stationarity first, you check for autocorrelation. Now this model is looking good. Now, for example, I'm saying this p-value is here, say 0.4, and this p-value is here, say 0.3. Now everything is so good in this, isn't it? P-value is also significant. Coefficients are also good. Adjusted R-square is mashallah 98%, right? Overall significance is very good, very much significant. Everything is so good. Wow, great. We have built up a very good model. Chalo, ab to paper likh denge is pe, right? Okay. We to show the relationship between this, but no, you cannot. Right? Next step is to verify the CLRM assumptions, classical linear regression model assumptions. And that is to check for autocorrelation, for multicollinearity, for heteroscedasticity. Right? Okay. So that is the higher side of this. Okay. So whatever model you are doing, that depends on this. For example, on day 5, you will do factor analysis. Okay. So there is a different assumption, different result for that. So I'm talking about regression model here, right? Okay. So everything is good here, but there might be a case when you check the stationarity, your series is not stationary. Now stationary is a different term I'm introducing here, but I want you to read more on this later, right? We're not covering it here because we cannot check stationarity here in Excel. For that you need statistical software, Stata, SPSS, or eViews, or SAS, any other software, or R, right, for that matter. Okay, so first you check the stationarity. Now your series, this series is not stationary. What you will do? You cannot work on this model and show this model on your paper. Okay, so this is your OLS, ordinary least square method, simple analysis. Okay, right? But in Excel, you can do this primary thing. Okay, then you can go for a software thing. So is this clear to all or no? I can understand, like in such a short period of time, it is difficult to understand, right? But you will get the recording. You can like check the recording later at your home. Okay, so any question, anyone on this, please tell me. Please tell me. Any question, anyone? Komal, is this clear? Pooja Prasad, Gurpreet Kaur, Gitika Agarwal, Priyanka Yadav, Dr. Shikha Agarwal, Mamta Dabas. Does it make sense to you? I have not heard from any one of you.
Ma'am, in a short time, you have explained beautifully what are the nitty-gritties of this issue.
Okay, thank you.
Thank you very much.
Okay, okay. All right. Now, like, this is what I wanted to teach you for the today's session. Now, this is your exercise data, right? For this data, so you will get attendance and certificate if you will give me the regression analysis of this. Okay, first I want, question number 1 is I want descriptive statistics of this data, and question number 2 is summary output of regression.
Ma'am, hello, speaking, ma'am.
Yes.
Ma'am, can you please write down these points?
Ma'am, what is the difference between descriptive statistics and summary output? Because summary output will automatically come when we give the command for descriptive statistics.
So that will be there in the regression. Yes, so that's why descriptive if you want only descriptive statistics, then you can pick go to the descriptive statistics option. Otherwise, like if you go to the regression, your mean, median, this thing is absent, no? Right?
Okay, so you are speaking about only regression part, correct?
No, no. I want, like we did here. No, we calculated the descriptive statistics, isn't it?
Right.
This one. So I want this table for this data plus this summary, this thing, plus the regression sheet.
Okay.
Okay, right? And in under regression, I want the answer of these 5 questions. Answer of these 5 questions. Do you remember 4 questions, whatever I said? If you do not know the question, should I repeat?
Not required.
Yes, ma'am, please repeat.
Okay, I'll write it in the chat box. So question number 1 is, how much of the data question number 2 is this a good model? Right. Question number 3 is, what is the relationship between X and Y variables? Now it is up to you for that sheet, because there are so many. First you identify which one is dependent, which one is independent. I am not telling you, right? And it is up to you. You want to do it a multiple regression model, or you can select one variable also. That is also fine. Okay, because the major objective is to make you understand. Then, do I have a good variable? So these 4 questions you need to answer for this data set exercise data. Clear? Yes. So any question, anything, please tell me. And I want descriptive statistics as well. Sticks and summary output. So should I stop here? You want to ask anything, right? Please work on this exercise, and you can share your results on WhatsApp group.
Ma'am, in case of descriptive statistics and summary, so you want for each individual column?
No, for the dependent variable.
For?
Dependent variable, whatever dependent variable you select. Okay?
Okay. Okay. Nice, ma'am.
Okay. So I hope this session makes sense to you, right? The basic idea was to make you learn the regression, how does it work, and the histogram and the descriptive statistics, and how do we do the interpretation. I have tried my best to explain little on it, but you need to read more, right, to get used to these terms. Okay, attendance link and this thing Monica ma'am will share, right, on the WhatsApp group. I guess everybody is there on WhatsApp group.
Yes.
Yes, no, everybody is there on the WhatsApp group. So we'll share this on the WhatsApp group. So please mark your attendance and feedback on that. So should I stop for the day, or any other query or anything you want to share, or please tell me.
No, it was wonderful, ma'am. It was in a short time we could get so many tips on regression, which is a very difficult topic to comprehend. But you made it very simpler, and the points in 5 questions you explained it in very granular level. I think many people will get benefit out of this workshop.
Okay.
Thank you very much.
Thank you. Thank you so much for the feedback. Yes.
Ma'am, please,
Okay.
once this is over, please share the link as well for this recording.
Recording, yes, you will get the recording link, I guess, by today or tomorrow. I cannot promise, yeah, but definitely you will get it. Okay.
Okay, ma'am.
All right.
Thank you.
Okay, so for day 4 and day 5, for day 4, Dr. Rishi will take the session and he will explain you about the theory of the concepts, right? And on day 5, you will get hands-on on SPSS. So, so you will be learning from him like on day 4 and day 5, right? All right. And still, like if you have any query, anything, I'm there on the WhatsApp group, so you can ask your queries related to regression. Okay. Mitali Shah. Okay. Only Mitali is not there on the WhatsApp group. If anybody else is also not there, please tell me. Okay, so just to wait, Mitali, I'll write your number. I'll add you. 473-662. Okay. Okay, I'll add you. Thank you so much. You are wonderful learners, and
Thank you, ma'am.
I'm very happy to take your sessions. Okay, see you
Thank
on
you,
day
ma'am.
5.
Thank you so much for this contribution.
Thank you, ma'am.
Okay, thank you. Now,
Thank you, ma'am.
Thank you, Mobinji. And now I'm waiting for your answers on the WhatsApp group. Okay, do not forget about this after the closing of this session. Please send your results of the regression, right? And your queries on WhatsApp group. Okay. Okay. Thank you, Mobinji.
Thank you. All the best.
Yeah. Thank you, Mobinji. Please.
Yeah. Yes, sir. Thank you very much, and all the best for your career. And hope many students will show their respect for you for whole life by learning small tips which make their output more valuable and more comprehensible by other.
Yeah. Yes.
Thank you. All the best,
Thank you so much. Thank
Thank
you.
you, ma'am.
Thank you. Mobinji, please close the session.